All right, good morning, guys. Today we're going to look at SPI 4.3. That's amplitude and period of trig models. That's just taking your sine, cosine, tangent curves and talking about how wide they are or how tall they are. That's all amplitude and period mean. So we're not going to actually do any graphing. They're going to give you a graph. You're going to analyze the graph a little bit. So let's look at this first example. The following graph shows the average monthly daylight in a particular city over 2 years. The function describing this graph is a transformation of the parent sine function y equals sine of x. We don't have to do anything with that. If all this says is if we were to graph y equals sine of x, it would look similar to this. What they want to know, which value best describes the amplitude of the transformed function? So when we see the word amplitude, we need to think the wave's height. Well, don't think overall height, because you think of a wave doesn't just go all up or all down. Waves will bounce back and forth, high, low, high, low. So when we're talking about amplitude or the height of a wave, it's how far from when it's at rest. Okay, so it's that vertical displacement. So there's two ways to look at it. One is the height from the midline. Think of this as if everything was at rest, it would be here at 11. The amplitude is how high we are off of that midline. So from 11 up to 16 gives us a height of 5. So the amplitude is 5. Pretty straightforward. Another way some people do it is they'll take the overall height and divide it by 2. So from 6 to 16 is 10. 10 divided by 2 is 5. So you get 5 hours. Either way you look at it, it doesn't matter. But the important thing to remember is it's not the overall height, it's half of that. So it's the height from the midline, from that middle, from when everything's at rest. That vertical displacement from equilibrium, if we're going to sound really mathy. Now let's look at the next example, which talks about period. The bob of a simple pendulum is released from a point and its swing is modeled by a cosine function. So if we graphed a cosine function, it would look something like this. What is the period in seconds of the oscillation? So they want to know period on this one. Well, period is the wavelength. That's how wide one cycle is. How wide until the pattern starts to repeat. So distance from peak to peak or valley to valley. Those are the easiest points to identify typically. Where are my high points? Where are my low points? So people will just grab those, and as soon as I get from one peak to the next peak, it starts to repeat again. So I'm just going to grab these two down here. You can see it's the same distance between all of them, so it doesn't matter which ones I grab. It's just you want consecutive peaks or consecutive values. So I'm going to grab these two, and we can see from 7 to 9 is 2, so the period of this function is 2. Pretty straightforward. Amplitude is how high from the midline, and period is how far from one peak to the next, how far until the cycle starts to repeat. And that's it for amplitude and period of trig models. I'll see you in class tomorrow, guys.